Welcome back. So, in the last lecture we just started discussion on the earth pressure on retaining wall. So, there we have seen that how you will be getting or how the earth pressure at rest, at passive, at active condition are going to develop. So, those things we have seen in the last lecture. So, now in this lecture we will be talking about the elastic equilibrium and we will be trying to establish the relation or trying to establish the expression for earth pressure at rest and earth pressure at active and passive condition. So, if the wall is rigid and does not move with pressure exerted on the wall, the backfill soil will be in state of elastic equilibrium. That means, when the wall is not moving at all, when the wall is at rest condition, when the backfill is at rest condition, at that time basically the soil will be under elastic equilibrium. So, what does it mean? So, if I look at this figure, so this is the wall which is having the height say capital H. We are considering at some depth z from the top surface of the backfill, we are considering one soil element. So, this soil element will be under this kind of state of stress. On the horizontal plane you will be having sigma v, and on the vertical plane you will be having sigma h. So, horizontal and vertical plane both will be your principal planes, right, because there is no shear stress on these planes. So, they must be the principal planes. Now, if we consider this soil element whatever is shown at depth z below the ground surface. So, considering this element sigma v is nothing but gamma z, as I told you in the last lecture, and sigma h it is nothing but the lateral pressure, am I right. So, which is nothing but your objective function which needs to be determined. Okay. So, sigma v is known to you because if you know at what depth you are considering, okay. So, you know the depth, you know the unit weight of the soil depending on the situation of the water table and all, we will come to that point later on. So, based on that you can find out sigma v. So, once you know sigma v, you can find out sigma h if you know the relation between sigma v and sigma h, am I right. So, sigma h is nothing but your lateral earth pressure, which is, I mean, in case of earth pressure rest condition, this is the earth pressure at rest. In active situation it will be the active pressure, and it is in passive situation it will be the passive pressure, right. This lateral pressure is nothing but the earth pressure. Okay. Now, earth pressure coefficient is defined by this expression, where earth pressure coefficient K is nothing but equal to sigma h by sigma v. So, in different situations, in different conditions, whether it is under rest condition, whether it is under active or passive condition, depending on the situation you can find out this earth pressure coefficient. So, earth pressure coefficient at rest condition, earth pressure coefficient at active condition, earth pressure coefficient at passive condition. So, once you know the earth pressure at different conditions, right, earth pressure rest, if you know this earth pressure coefficient, then you can find out sigma v, provided if you know sigma v, sorry. So, basically this earth pressure coefficient at different conditions we are going to find out. Earth pressure at rest, earth pressure at active, earth pressure at passive. So, this earth pressure coefficient we are going to obtain, or we are going to formalize this thing. So, once you know this earth pressure coefficient, and if you know sigma v, that is obviously at some depth you are considering. So, sigma v is known to you. So, if you know sigma v, if you know the earth pressure coefficient, you can find out sigma h, that is nothing but your earth pressure, that is a lateral earth pressure at different conditions. If you are using earth pressure coefficient at rest condition, then you will be getting earth pressure at rest condition. If you are using earth pressure at active condition, you will be getting earth pressure at active condition. So, in that way you can find out sigma h. Okay. So, now first we are going to find out earth pressure coefficient at rest condition. So, earth pressure coefficient rest condition is defined by K naught, which is nothing but sigma h by sigma v, that is the definition of the earth pressure coefficient. Therefore, that is nothing but sigma h. Now, what is sigma v? That is nothing but gamma z, am I right. So, if you know K naught and if you know at what depth you are considering, so therefore, sigma v is known to you, you can find out sigma h. So, from this I can write sigma h equal to k naught into gamma z, right. K naught is nothing but the earth pressure coefficient at rest condition into gamma into z. Now, by seeing this variation, we can get the variation of the lateral pressure from top to bottom of the wall as linear. So, this is shown here. So, at z equal to 0, what is sigma h? It is 0. Okay. So, that is here. At z equal to h, what is your sigma h? Sigma h is equal to k naught into gamma h. So, that is here. So, this is the pressure. So, it starts from 0 and ending at k naught gamma h. So, this is the earth pressure distribution, okay, variation of earth pressure at rest condition along the wall height. Is that clear? So, at any depth you can find out earth pressure at rest condition. Okay. So, now if you want to find out the total pressure, that is the total thrust at rest condition, that is nothing but the area of this triangle. So, area of this triangle is P naught equal to half into k naught into gamma h square, right, because we are considering this all these problems as plane strain problem, that is the direction normal to this board or normal to this plane, okay, is unit. Okay. So, this P naught is equal to half into k naught into gamma h square, that is nothing but the total pressure at rest condition, that is the total thrust acting on the wall and which will be obviously acting at the CG of this triangle, that is at h by 3 from the base of the triangle. Okay. So, this is the point of application of this thrust and this is the total thrust. So, based on that you can design the wall. So, this much, I mean the wall should be designed based on this pressure and at that level that pressure is acting, or the total pressure rather, total pressure is acting, and based on that you can design the wall. Okay. That is earth pressure at rest condition. Now, in all these equations or the formulation, we know how to find out sigma h, we know how to find out the total pressure and all those things, but provided if we know k naught. K naught is nothing but earth pressure at rest condition. If I know this k naught value, then only I can find out the magnitude of the total pressure, total thrust, pressure at different locations and all those things, right. Sigma h is only known when you know k naught value. So, let us find out how to find out k naught. So, value of k naught. So, lateral strain generally, I mean you know from the Hooke's law, lateral strain is given by this expression. So, this is very simple, that is coming from your mechanics, that is epsilon h, that is your lateral strain, is equal to 1 by E into sigma h minus mu into sigma v plus sigma h, because this is the 2D problem, 2D plane strain problem. So, that your epsilon h is given by this expression and this is coming from your Hooke's law, right. Now, for rest condition, what is epsilon h? Epsilon h, what is epsilon h? That is the lateral strain, that is the movement of the wall, that is the strain happening in the soil. So, earth pressure at rest condition, if you consider the rest condition, at that time what is the lateral strain? Lateral strain is 0, there is no movement in the soil backfill. So, epsilon h is 0. If epsilon h is 0, so I can write sigma h minus mu into sigma v plus sigma h is equal to 0. From this I can write sigma h is equal to mu by 1 minus mu into sigma v, which is nothing but k naught sigma v. Therefore, k naught is mu by 1 minus mu. Okay. So, what is mu? Mu is the Poisson ratio. So, if you know the Poisson ratio, you can find out the magnitude of k naught. So, once you know k naught, you can find out sigma h at different locations and as well as the total pressure or the total thrust on the wall at rest condition. Now, Jackie in 1944, he proposed that k naught can be taken as 1 minus sin phi, where phi is the angle of internal friction of the soil, and it has been found that this value of k naught gives very good or reasonable result in the soil mechanics. Now, in case of active condition, we are trying to obtain this kind of say, or we are trying to develop this earth pressure coefficient or the relation between the vertical pressure and the horizontal pressure in case of active state. Now, and that was proposed by Rankines. Okay. So, therefore, that is why it is known as Rankine's earth pressure theory for cohesionless soil. So, first we are considering the cohesionless soil, that means C is 0. Okay. So, at that time we are considering again similar thing, this is the wall. So, we are considering one say small element at some depth z, okay, from the ground surface, h is the total depth of the wall. So, again the earth pressure distribution at active state will be, so this is the earth pressure distribution at rest condition K naught into gamma h, already we have established that, and already you know that your earth pressure at active condition will be lesser than your earth pressure at rest condition, right. Now, we need to find out the variation. So, we will see that this variation will be also linear, and because your sigma h by sigma v is Ka, where Ka is nothing but the earth pressure coefficient at active condition. Okay. We need to find out Ka. Now, this once you know Ka, which will define how to find out, if you know sigma v, you can find out sigma h, which is nothing but the lateral earth pressure at active condition. So, sigma h is nothing but Ka into sigma v. Okay. So, this relation or this Ka further can be written as Ka into gamma z, am I right. So, at z equal to 0, your sigma h at active condition will be 0, same, okay, as rest condition. Now, when z equal to h, at that time sigma h will be Ka into gamma into h. So, that is written here Ka into gamma into h. Okay. So, and the variation is linear. So, therefore, this is your variation of the active earth pressure, which will be lesser than your earth pressure at rest condition, but it will be always linear. Okay. So, now, in this figure if you look at, so in case of active state, what is the direction of the major principal stress? The direction of the major principal stress is vertical. So, this is the direction of the major principal stress, right. So, therefore, what will be the direction of minor principal stress? That will be just 90 degree from the major principal stress direction. So, that will be simply horizontal. This is your minor principal stress direction. Okay. So, now, if you recall your Mohr circle representation, in the Mohr circle, in case of this kind of orientation, when sigma 1 is acting in the vertical direction and sigma 3 is acting horizontal direction, in this situation, okay, horizontal direction means sigma 3 is acting on the vertical plane and sigma 1 is acting on the horizontal plane. In that situation, in the Mohr cycle, if you recall from your mechanics point of view, then basically the slip lines, that means we will come to that point later on, the slip lines will be making an angle 45 plus phi by 2 with the horizontal. Horizontal means the plane on which sigma 1 is acting. Sigma 1 is acting on the horizontal plane, because sigma 1 is acting in the vertical direction. So, sigma 1 is acting on the horizontal plane. So, the line which is making an angle 45 plus phi by 2 with the horizontal plane will be the slip lines, okay, the shear lines, right. So, there will be two shear lines, because from the top you will be having one failure envelope and the bottom you will be having another failure envelope. So, you will be getting two shear lines, and those shear lines, and that is why this failure, as I told you, this will be making 45 plus phi by 2, because that is your shear line. Along that line basically the failure will be happening. Okay. So, I told you that we will be discussing this thing later on anyway. So, we will see this thing in more detail when we will be talking about the Mohr cycle representation. Now, talking about the passive condition, at that time also we are considering this state of stress. Okay. So, one soil element we are considering here, also your sigma h is equal to Kp into sigma v, which is nothing but Kp into gamma into z. Okay. So, now you see this dotted line is your earth pressure rest condition, that is the variation at earth pressure rest condition. Okay. Now, this solid line will be giving you the earth pressure at passive state. So, at z equal to 0 it is 0, at z equal to h it is Kp into gamma h, which will be greater than your earth pressure at rest condition. Agreed? So, earlier in case of active state you got the lesser value than the rest condition, now you are getting the higher value than the rest condition, which is quite obvious from our earlier discussion. Again, in this situation, in case of passive state, if you see what is the direction of the major principal stress, direction of the major principal stress is horizontal, right. In case of active state, direction of major principal stress was the vertical, now it is horizontal. That means you are pushing, this is your main action, right, you are pushing the wall towards the back peel. So, that should give you the major principal stress. So, what is your minor principal stress? What is the direction of the minor principal stress? That is nothing but vertical. So, this is your major principal stress direction and this is your minor principal stress direction, which is just reverse than the active state. Okay. And if you plot, so that means now basically your sigma 1 is acting horizontally and sigma 3 is acting vertically. So, in this situation, in this condition, okay, so this condition if you try to plot in the Mohr circle, you will be getting the shear lines which will be making an angle 45 minus phi by 2 with the plane on which sigma 3 is acting, right. Sigma 3 is acting on horizontal plane, now sigma 3 is acting on horizontal plane. So, 45 minus phi by 2 is the angle between the shear lines and the horizontal plane on which sigma 3 is acting. Now, this thing will be clear when we will be talking about the Mohr circle representation. So, therefore, you will be getting the failure surface which will be inclined 40. So, already we have seen. So, this shear lines will be making an angle 45 minus phi by 2 with the horizontal plane. Okay. So, therefore, this failure envelope or the failure surface in case of passive state will be making an angle 45 minus phi by 2. So, that is the reason, that is why you are getting this failure surface is inclined at 45 minus phi by 2 with the horizontal in case of passive state, whereas in case of active state you got the active, I mean the failure envelope or the failure plane is inclined at an angle 45 plus phi by 2 with the horizontal, right. So, now if you see this Mohr circle representation, it will be more clear. So, this is the Mohr circle CA, that is Mohr circle for active state, and CP is the Mohr circle for passive state. So, and as I told you, your sigma V is same for passive state or active state, whatever state you consider, sigma V is gamma z, because you are not changing the location at which you are considering that soil element, whatever soil element we consider. So, sigma V will be remaining same for active and passive state, whereas your sigma 3 for active state and sigma 1 for passive state will be different. This P1 point will be talking about this sigma V. So, you are starting from this. So, active state circle, this circle is giving you the active state, and therefore, this point P2 is nothing but your active earth pressure, that is your minor principal stress, and minor principal stress is nothing but the lateral earth pressure in case of active state, and that is eventually your active earth pressure. Whereas, in case of passive state, this P1 becomes the minor principal stress, whereas this P3 point is becoming the major principal stress, which is giving you the lateral pressure and which is nothing but the passive earth pressure. Okay. So, now as I told you this, so this is the plane, this is the first shear line and this is the second shear line, right. So, because you will be getting the Mohr Coulomb failure envelope on both the sides. So, this is your first shear line, this is your second shear line, which is making an angle 45 plus phi by 2. So, I am not going to much detail about how to draw this, how to obtain this shear line and how to get this first shear line, second shear line, because this is a part of your mechanics and which is eventually your prerequisite of this course. So, you must know that how to get these planes on which the failure is happening. So, this is your first shear line which is making an angle 45 plus phi by 2 in case of active state. So, that is why you are getting the failure line or the failure envelope which is making an angle 45 plus phi by 2 with the horizontal. But on the other side, in case of passive state, you are getting this angle as 45 minus phi by 2, right. So, if you recall, I mean just for sake of brevity, okay. So, this point will be becoming as the pole, that is the origin of planes, and this point will be becoming as pole which is nothing but the origin of planes in case of passive state. So, P1, P2 is your origin of planes, that is the pole in case of active state, and so from this point to the failure point if you join, so on that plane you will be getting the failure. Similarly, this is the point P3 will be the pole in case of passive state. So, if you join P3 and C2, so you will be getting the failure. So, this is your first shear line, this is your second shear line which will be making an 45 minus phi by 2 angle with the horizontal, and that is why you are getting the failure line or the failure envelope is inclined at an angle 45 minus phi by 2 in case of passive state. I hope that you have understood this. Okay. Now, coming to the Mohr cycle for active and passive states of equilibrium. So, vertical stress on horizontal plane at any depth z is nothing but sigma v, which is nothing but equal to gamma z. This is your principal stress, right, one of the principal stress. If you are considering active state, this will be your major principal stress. If you consider the passive state, it will be your minor principal stress, right, but it will be your one of the principal stress. Okay. Since shear stress on the plane is 0, because the principal, I mean the on that plane basically your shear stress is 0. So, that is why it is becoming the principal stress, right. And from the Coulomb's equation I know tau f equal to sigma tan phi, because C is not there, we are not considering the cohesive soil for the time being, as we told that we are considering only cohesionless soil, cohesive soil will be coming later on. So, the for active or passive state sigma v is always equal to gamma z, please try to remember. Sigma v could be minor, could be major depending on the situation whether you are dealing with active or passive state, but sigma v will be unchanged and sigma v will be equal to gamma z whether you are considering active state or whether you are considering passive state, no matters whatever state you are considering. So, in case of active state of stress, so from the Mohr cycle Ca, as I told you, in the active state of stress the major principal stress sigma 1 is equal to O into OP1, okay. So, O is the origin, okay, and P1 is this point. So, OP1 is your sigma 1 which is nothing but your sigma z, that means sigma v, right, sigma z and sigma v both are same. So, in the z direction, that is why I have written sigma z to understand this thing more clearly. So, sigma z is equal to gamma z. So, sigma 1, that is the major principal stress in case of active state, is gamma z. Now, what is the minor principal stress then? Minor principal stress is nothing but sigma 3 which is nothing but OP2, okay. So, OP2 is nothing but sigma h which needs to be determined, sigma h is your active pressure. So, OO1, what is OO1? That is the distance between the center of the Mohr circle here, this is O1, center of the Mohr circle and origin, okay. So, O1 is sigma 1 plus sigma 3 by 2. I do not think that I should explain this thing in more detail, because already we have explained enough in the chapter when we discussed about shear strength. So, O1 equal to sigma 1 plus sigma 3 by 2. Similarly, O1 C1 is the radius, that is nothing but sigma 1 minus sigma 3 by 2. So, from triangle O1 C1 we get this relation, right, am I right. So, from this I can write sigma 1 is equal to 1 plus sin phi by 1 minus sin phi into sigma 3. So, what does it mean? Sigma 1, so if you see the previous slide, sigma 1 is equal to 1 plus sin phi by 1 minus sin phi into sigma 3. Now, what is sigma 1? sigma 1 is nothing but your sigma v, right, that is nothing but your gamma z. What is sigma 3? Sigma 3 is your lateral earth pressure, that is sigma h, right. So, I can write sigma h is equal to 1 minus sin phi by 1 plus sin phi into sigma v. Now, from the relation of your earth pressure coefficient, this therefore, I can write this is equal to sigma v. So, now Ka is nothing but 1 minus sin phi by 1 plus sin phi. So, if you know the angle of internal friction phi, you can find out what is your active earth pressure coefficient, right. So, once you know Ka and already you know sigma v, you can find out sigma h, that is how much active earth pressure is exerted on the wall by the backfill. So, I will stop here today. So, in the next lecture we will talk about, or we will try to find out the magnitude of Kp and we will move further. Thank you very much.